Good morning, all of you. Today we're going to discuss some important organic compounds. Though there are so many important organic compounds in this class, we're going to discuss two compounds particularly. They are ethanol and ethanoic acid. So first let's go for the discussion of ethanol. It is otherwise commonly called as ethyl alcohol, which is having molecular formula C2H5OH. It is quite similar to water in its physical and chemical properties. Water can be written as HOH, H2O. In water, if hydrogen atom is replaced by ethyl group, C2H5 group, then ethyl alcohol is produced. So this ethyl alcohol can be commercially prepared by hydration of ethene. Hydration means addition of water. Ethene, when subjected to hydration, it produces ethyl alcohol or ethanol. For hydration of ethene, we require a catalyst like phosphorus pentoxide. We require high temperature and high pressure. So ethanol is obtained by hydration of ethene in presence of catalyst like P2O5 and at a high temperature and pressure. If you write a chemical equation for that, C2H4, that is ethene, is hydrated, means treated with water, in presence of catalyst like P2O5, high temperature, it will be requiring a temperature of around 150 to 200 degrees Celsius and a pressure of 200 atm. It produces C2H5OH, which is nothing but ethanol or ethyl alcohol. In some places around the world, this alcohol can be prepared by the process of fermentation. You may be familiar with the definition of fermentation, which will be facing in biology. Fermentation is nothing but splitting of large complex molecules into simpler molecules in the presence of enzymes. Splitting of large and complex molecules into simple molecules in the presence of enzymes is called fermentation. So that fermentation of grains like barley. Fermentation of grains like barley is used for making up of this alcohol on large scale. That's why this alcohol is otherwise referred to as grain alcohol, as it is prepared by fermentation of grains. It is referred to as grain alcohol in treatment. In India, at most of the places, this alcohol is prepared by fermentation of molasses. Molasses is a foul-smelling liquid obtained as byproduct in sugar industry, which is containing 50% by weight of sugar. What is molasses? A foul-smelling liquid containing 50% sugar, which is nothing but sucrose. That is a byproduct of sugar industry. that molasses is fermented to produce alcohol. I said to you fermentation takes place in the presence of enzymes. Here also, fermentation of sucrose present in molasses is carried out by two enzymes, namely invertase and gymase. So invertase catalyzes hydrolysis of sugar. That means splitting up of sugar molecule by chemically reacting with water. That process is catalyzed by invertase. So invertase catalyzes hydrolysis of sugar to glucose and fructose. You have noted glucose and fructose are isomers. They are having same molecular formula but different structural formula. So if you see that C12 H22O11, that is sucrose, when it is subjected to hydrolysis, it produces glucose and fructose, which are having same molecular formula but different structural formula they will be having. Then gymase catalyzes conversion of glucose to alcohol. Glucose, which is C6H12O6, in the presence of gymase, will get converted to C2H5OH plus CO2. CO2 is a byproduct of alcohol manufacturing units that use molasses as a starting material. The alcohol obtained here is just having a concentration of 15 to 20%, that is referred to as wash. 15 to 20% concentrated alcohol obtained after fermentation is known as wash. So 15 to 20% alcohol is known as wash. That wash is to be subjected to further concentration by the technique of fractional distillation. On subjecting wash to fractional distillation, I'll be getting 96% alcohol, which is known as rectified spirit. 96% alcohol is known as rectified spirit. That rectified spirit, on treating with calcium oxide, loses its remaining 4% water and gets converted to 100% alcohol, which is known as absolute alcohol. 100% alcohol is known as absolute alcohol. Absolutely alcohol, nothing is there in that. That is obtained by treating rectified spirit with calcium oxide. This 100% alcohol, which is known as absolute alcohol, is transported to alcoholic beverage industries and pharmaceutical industries, where ethyl alcohol is used as starting material. So while transporting, to prevent the misconsumption by fourth class people like drivers and cleaners, this absolute alcohol is contaminated by addition of some external substances like methanol, methyl butyl ketone, aviation gasoline, etc. That absolute alcohol, which is contaminated with methanol, methyl butyl ketone, and aviation gasoline, is known as denatured spirit, which is unfit for consumption. Absolute alcohol added with methanol or methyl butyl ketone or aviation gasoline is called denatured spirit. After it is received at that industrial unit, they will be removing these substances, methanol or methyl butyl ketone or aviation gasoline, and then further processing for their use. Okay, this is about manufacture of alcohol. Now coming to properties of alcohol, physical and chemical properties. Physical properties, if you see, ethyl alcohol is a clear colorless liquid with a characteristic odor. It's having a strong odor. Ethyl alcohol is a clear colorless liquid with a characteristic odor that is highly soluble in water. That means ethyl alcohol is soluble in water to any extent. It is soluble to any extent. And ethyl alcohol is having a boiling point of 78.3 degrees Celsius. It's having 78.3 degree Celsius. That's the boiling point of ethyl alcohol. While coming to chemical properties of ethyl alcohol, at the starting I said to you that ethyl alcohol is quite similar to water. In water, hydrogen atom is replaced by ethyl group, then I'll be getting ethyl alcohol. Coming to chemical properties, ethyl alcohol exhibits some of the properties of water. Just when water is added to sodium metal, a vigorous reaction takes place resulting in release of hydrogen gas. In the same way, on adding a lump of sodium metal to ethyl alcohol, a brisk reaction takes place resulting in release of hydrogen gas. CH3, CH2OH, when it is added with sodium metal, the CH3CH2OH is nothing but ethyl alcohol. A brisk reaction takes place resulting in formation of C2H5ONa plus H2. This is nothing but sodium ethoxide. C2H4ONa is nothing but sodium ethoxide along with release of hydrogen gas. If you balance that, okay, sodium ethoxide and hydrogen gas are produced. Then coming to reaction of ethyl alcohol with concentrated sulfuric acid. When ethyl alcohol is treated with concentrated sulfuric acid at 443 Kelvin, that is nothing but 170 degrees Celsius, ethyl alcohol undergo dehydration to produce ethane. What is that? Ethane is produced. So C2H5OH, when heated with concentrated sulfuric acid at 443 Kelvin, it undergo dehydration to produce ethane. Ethyl alcohol on treating with concentrated sulfuric acid at 443 Kelvin produces ethane. That is dehydration reaction of ethyl alcohol. This ethyl alcohol, on being treated with ethanoic acid, then actually ethanol and ethanoic acid, when just mixed, they don't react with each other. For that reaction to take place, concentrated sulfuric acid is to be added and reaction mixture is to be subjected to action of heat. Then a fruity odored substance known as ester is obtained. So if you see C2H5OH, when it is added with CH3COOH, when it is heated and concentrated sulfuric acid is added, which act as a catalyst and dehydrating agent, it produces CH3COOC2H5 plus H2O. This is nothing but ethyl ethanoate, that is ester, which is having a fruity odor. That particular reaction can be referred to as esterification reaction. What is esterification reaction? Reaction in between ethyl alcohol and ethanoic acid in presence of concentrated sulfuric acid to produce ethyl ethanoate, which is having fruity odor, is known as esterification reaction. This coming to uses of ethyl alcohol, you all know most of the alcohol is used in pharmaceutical industries. It is used as solvent, and alcohol is used for making of beverages. In cold countries, Mixture of 10% alcohol, 10% alcohol and 90% gasoline, which is referred to as gasohol. Very much important that is. What is gasohol? Mixture of 90% gasoline and 10% alcohol is referred to as gasohol, which is used as fuel in cold countries. What is gasohol? Mixture of 90% gasoline and 10% alcohol is known as gasohol, which is used as fuel in cold countries. This is about ethyl alcohol. Next, coming to ethanoic acid. That is commonly called as acetic acid. Ethanoic acid, which is commonly called as acetic acid. Having molecular formula CH3COOH. This is obtained by oxidation of ethyl alcohol. When ethyl alcohol is heated with acidified potassium dichromate or alkaline potassium permanganate, it will get converted into ethanoic acid. So CH3CH2OH on treating with acidified K2Cr2O7 or alkaline KMnO4, it undergo oxidation to produce ethanoic acid. Just like ethyl alcohol, ethanoic acid is also a clear colorless liquid with a typical odor. Ethanoic acid is a clear colorless liquid with a typical odor. It is soluble in water in all proportions, just like alcohol. Ethanoic acid is soluble in water in all proportions. It is clear colorless liquid having typical odor, and it is soluble in water in all proportions. Coming to chemical properties of ethanoic acid, as it is acid, its properties resemble the properties of acids which we had discussed long back. So CH3COOH on being treated with sodium metal, when a small piece of sodium metal is added to ethanoic acid, a brisk reaction takes place resulting in formation of CH3COONA plus H2. This is sodium ethanoate. We should not get confused for the reaction of alcohol and carboxylic acid with sodium. Ethanol and ethanoic acid both react with sodium metal resulting in hydrogen gas. But in the case of ethanol, sodium ethoxide is produced. In the case of ethanoic acid, sodium ethanoate is produced. This CH3COOH on reacting with sodium bicarbonate produces brisk effervescence, regular produce होता है, due to release of carbon dioxide gas. On adding lump of sodium bicarbonate to ethanoic acid, a brisk effervescence occurs due to release of carbon dioxide gas. CH3COO Na plus H2O plus CO2 gas. That CO2 gas produced comes out in the form of bubbles, producing brisk effervescence. As a matter of fact, this reaction is used to distinguish in between ethanol and ethanoic acid. We have seen ethanol and ethanoic acid, both are clear liquids, both are colorless liquids, both are highly soluble in water, both react with sodium resulting in same gas, hydrogen gas. So how do you distinguish in between ethanol and ethanoic acid? Ethanol and ethanoic acid can be distinguished by their reaction with sodium bicarbonate. On adding lump of sodium bicarbonate to ethanol, nothing happens. Why? Because ethanol do not react with sodium bicarbonate. But on adding lump of sodium bicarbonate to ethanoic acid, a brisk effervescence occurred due to release of carbon dioxide gas. Okay, now coming to, I said to you that ethanoic acid exhibit the properties of acids, and you also know a strength of an acid is expressed in terms of pH. pH is nothing but negative logarithm of hydrogen ion concentration taken to base 10. Acids having lower pH are stronger acids. Acids having higher pH are weaker acids. We are discussing regarding carboxylic acid, which is an organic acid that is having very high pH, close to 7. So I can say that ethanoic acid is a weak acid. Our strength of acid can be expressed in terms of Ka, which is nothing but dissociation constant. That means how far an acid undergo dissociation to furnish H plus ions in aqueous solution is expressed in terms of dissociation constant. Acids having higher dissociation constant, that means acids having higher Ka values are strong acids, whereas acids having lower Ka values are weak acids. If I take pKa, pKa is nothing but negative logarithm of Ka taken to base 10. This is just similar to pH. pH is nothing but negative logarithm of hydrogen ion concentration taken to base 10. pKa is nothing but negative logarithm of Ka taken to base 10. Higher the Ka, higher the acid dissociation constant, lower the pKa value, then stronger the acid. Lower the Ka value, higher the pKa, then weaker the acid. Based on this, you will be getting bits in NTSE and Polycet exams. Then I said to you that acetic acid is soluble in water in all proportions, that 5 to 8% aqueous solution of ethanoic acid. 5 to 8% aqueous solution of ethanoic acid is referred to as vinegar, which is used as preserving agent in edible industry. With this part is over. Still remaining is cleansing action of soap. Thank you.